Happy morning, my dear children. Today we are going to start a new lesson that is about the P block 1. In our syllabus, we have P block 1 and P block 2. All of you know that one. Group number 13 to group number 18 in the periodic classifications are called as P block element. Am I right? In this lesson, we have to discuss about that. The first element is about that boron and its compound, carbon and its compound, nitrogen and its compound. We can be discussed in this lesson. Okay. Please all of you take the note and textbook. We can be discussed one by one. Okay.
My dear children, today our learning objectives to learn about the general trends in the properties of P block elements. Describe the general trends in the properties of P block element. The periodic classification of elements are classified into 4 blocks. Number 1, S block element, P block element, D block element, and F block elements. In our 11th grade, we learn about the S block element. Remaining, the P block element and D block element and F block element we are going to learn about in 12th grade. Am I right? Next, the element. What is about the P block element? What is about the P block element? That means the element in which the last electron enters the P orbital. The last electron enters in the P orbital. That are called as what? P block element. Am I right? For example, first one I am taking that the first one is a boron atom. Okay, boron. What is the atomic number of boron? Atomic number of boron is 5. Am I right? How will you write the electronic configuration? EC is equal to 1s2, 2s2, 2p1. Okay, here the last electron enters where? The P subshell. So they are called as P block elements. We have 18 groups and 7 periods in the modern periodic table. Am I right? We have 7 periods and 18 groups in the modern periodic table. Here in the 13 to 18th group, the P blocks are occupying. Am I right? From the 13th to 18th, which one is the first element? Am I right? From the 13th to 18th group, which elements are the first? That means first 13th group, the first element is boron. 14th group, the first element is carbon. 15th group, the first element is nitrogen. 16th group, the first element is oxygen. 17th group, the first element is fluorine. And the 18th group, the first element is helium. Am I right? Here, these groups includes some non-metals, having metals, metalloids, and some radioactive element. The element of this block and their compounds play a very, very important day-to-day life. For example, oxygen. During respiration, we are taking oxygen. Am I right? It is we cannot imagine the survival of living system because of the absence of oxygen. What about the aluminium? It's the most abundant metal. Aluminium and its alloy having a plenty of applications. For example, most of the aluminium are used in our household utensil and to the parts of aircraft. Am I right? And about that semiconductor. Which are the semiconductors? Silicons and germanium. It's the most important. Okay. They are very used in our modern electronic appliances. Okay. So, in our this topic, we are learn about that boron family, carbon family and nitrogen family. Okay, the remaining, the next oxygen, fluorine, noble gas, these are all learning in our next lesson. That is a P block element 2. In this P block element number 1, first lesson, P block element 1, we are discussing only about the boron family, carbon family, and about the nitrogen family. What is about the boron family? Group number 13. What about the carbon family? Group number 14. What about the nitrogen family? Group number 15. Okay. So, how will you write the electronic configuration and oxidation state of the P block element? Okay. First you have to discuss about that. Electronic configuration of P block element. My dear children, the P block element having the general electronic configuration, that is NS2 NP 126. Can you understand me? What is the general electronic configuration? NS2 NP, that is NP subshell 126. For example, 13th group NP1, 14th group NP2, 15th group NP3, 16th group NB4, 17th group NP5, 18th group NP6. Like that they are arranged, am I right? So the general electronic configuration of P block element is NS2NP126. Here we have to write each one group, am I right? What is the general electronic configuration? For the boron family, what is the general electronic configuration? NS2NP1. Carbon family, what is the electronic configuration? NS2NP2. Next, about the nitrogen family, NS2NP3. Oxygen family, NS2NP4. Halogen family, NS2NP5. Noble gas, NS2NP6. Okay, can you understand? Already we learned in 11th grade, am I right? So take return practice how to write the electronic configuration. If you are feeling difficult means please ask me. Okay, next, the element of each group having similar outer electronic configuration. They have similar, each group having similar outer electronic configuration. Each group. First I am writing only 2 element in boron family. Okay, first element for the boron family is boron, aluminum, gallium, indium and thallium. Okay, so I am writing only the first 2 elements, that means boron and aluminum. What is the atomic number of boron? Atomic number of boron is 5. How will you write the electronic configuration? EC is equal to 1s2 2s2 2p1. Am I right? Next up, aluminium. What is the atomic number of aluminium? Is 13. How will you write the electronic configuration? EC is equal to 1s2 2s2 2p6 3s2 3p1. Am I right? So the outer electronic configuration is 2s2 2p1 for the boron family. Can you understand? 2s2 2p1. Okay, about the aluminium, 3s2 3p1. Okay, so we have, I hope that you may be thorough about how to write the electronic configuration. If you are not, if you have any doubt means please ask me. Next I will explain how to write the electronic configuration. If you have any doubt means, okay. Next, and about one more point, the element of each group having similar outer electronic configuration and differ in the value of n. What is about the value of n means? Here n refers as principal quantum number. We know that the quantum numbers are 4 types. Am I right? The first one is a principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Am I right? Anyhow, the first one is about the principal quantum number. Am I right? Here it denotes the shell of an atom. Am I right? shell of the atom. So I hope that you will thoroughly learn in our 11th standard. Okay. Anyhow, the element of the group 18. 18 means we are saying inert gas. What is about the inert gas? It is like completely filled in their subshell, in their p subshell. Am I right? So it never accept an electron and it is never donate an electron because it is a stable. Am I right? They have completely filled p orbital. They are more stable and least reactivity. This element shows variable oxidation. Example +3, +4, +5 and +6. And also having highest oxidation state. Highest oxidation state means group oxidation state. I will explain the next page. Okay, what is about the variable oxidation state, what is about the group oxidation state. Okay, I will explain. And one more, today our important point is what is the other observed oxidation state. Is very important, that also can be learned today. Okay, so the next page we have to learn that one. Okay, anyhow, valence electron means that is total number of electron present in the outermost shell, that we are saying there about the group oxidation state, that we learn that one. And about that, here S block element which shows only positive oxidation state. S block element, it shows only about positive oxidation. What is about the positive oxidation state? That is that electron, an atom lose its electron. Am I right? An atom lose its electron, it become positive. Suppose an atom accept an electron means we are saying that atom is gaining electron, that we are saying what? Negative oxidation. Am I right? Here, suppose the atom lose an electron means that process we are saying about an oxidation. An atom gain electron means that we are saying that what? Reduction. Okay, let us we can discuss next page. Okay, anyhow, here S block element shows the positive oxidation state, that S block elements donating their electrons. Am I right? The p block element having shows the negative oxidation state. Some, that is not all, some of the p orbital, some of the p block element having shows the negative oxidation. For example, a halogen group, halogen -1. Okay, negative oxidation state. The halogen have the strong tendency to gain of electron to give a stable halide ion. For example, my dear children, I'm giving only one example about the fluorine. What is the atomic number of fluorine? The atomic number of fluorine is 9. Am I right? The first shell we can be accommodate 2 electron. The second shell we can be accommodate remaining 7 electrons. Am I right? Because here having 9 electrons. First shell we can be accommodate 2 electrons. Second shell we have only 7 electrons. So 2 plus 7 is equal to, we have 9 electrons. Am I right? So for the inert, to attain the inert configuration, fluorine need 1 more electrons. Am I right? So only fluorine get 8 electrons. So if your fluorine get 1 electron from any other element means it becomes 2,8. So the fluorine element is converted into fluoride ion. Okay, that is F minus ion. So accepting means what? That is we are saying negative. Can you understand? So anyhow, the halogen have the strong tendency to gain an electron. Now fluorine gain 1 electron. Can you understand? Fluorine gain 1 electron to give the stable halide ion. Now halide ion means F minus ion. Am I right? So it get a completely filled electronic configuration. Plus -1 oxidation state is more common in halogen. Okay, and other elements such as nitrogen, that is about the 15th group. Chalcogen, nitrogen means the nitrogen family. Okay, 15th group. And the chalcogen means 16th group, that's oxygen family. Okay, also shows the negative oxidation state. Okay, negative oxidation state. Okay, my dear children, in this area, I'm explaining about that, this tabular column, I mean the page number 28. They have a tabular column. The tabular column, the left corner, the group name, am I right? They are having highest oxidation state, other absurd oxidation state. These are all very important. My children, please try to learn this area thoroughly, okay? Anyhow, the general electronic configuration and oxidation state of p block element. Oxidation state are very, very important. That also we learn thoroughly in 11th standard. Once again, we can be recall that one. Okay, oxidation state. First one, a group number. I told that p block element having 13 to 18th group. Am I right? Boron, carbon, nitrogen, oxygen, fluorine, and inert gas. 13th group, that name is called as an icosahgen. Okay, icosahgen, boron family. Next, about the 14th group means tetragen. Tetragen means, what is that one? Tetra means 4, am I right? What is atomic number of carbon? Atomic number of carbon is 6, am I right? First shell we can be accommodate 2 electron. Second shell is 4 electron, am I right? 4 means tetragen. Don't forget that. 4 means tetra. So carbon family we can be say tetragen. Next about that, nitrogen, nitrogen. Start with the N, am I right? Nitrogen, nitrogen. Don't forget that. And also the oxygen family, all of you know that one, chalcogen. Previously we learned about the chalcogen. And about the 17th group, halogen. Okay, fluorine, chlorine, bromine, iodine. And the 18th group about that, inert gas. Next about the common general electronic configuration of group number 13. Previously I told that NS2NP1 for the 13th group. Am I right? What about the 14th group? NS2NP2. What about the 15th group? NS2NP3. What about the 16th group? NS2NP4. What about the 17th group? NS2NP5. And the last one, NS2NP6. These are the general electronic configuration. Next, the two areas are very, very important, my dear children. For the each one having one word question, okay, each one. Highest oxidation state. What is about that? Highest oxidation state. Otherwise, we can be say group oxidation state. Highest oxidation state. Otherwise, we can be say the group oxidation. My dear children, here, what is about the highest oxidation state and the group oxidation? Here, group means, first I am writing the boron electronic configuration. What is the atomic number of boron? 5. Am I right? Atomic number is 5. What is electronic configuration? 1s2 is equal to 1s2, 2s2, 2p1. Am I right? So the last electron, the first one is first 1s means it is stable. Am I right? The last, that is 2s2 and 2p1. 2s2 and 2p1. What is about the 2 plus 1? 2 plus 1 means that is 3. So plus 3 is the highest oxidation state of group 13 element. Can you understand? Next one, about the 14th group. What is the general electronic configuration? NS2, NB2. Am I right? So example, carbon. What is the atomic number of carbon? Carbon is 6. How will you write the electronic configuration? E is equal to 1s2, 2s2, 2p2. So the last 2, we have how much electron is there? 2 plus 2, 4. So what is the oxidation state? Plus 4. Okay, leave it a 1s. We can take 2s and 2p. We are counting means we get plus 4. What is about the 15th group? General electronic configuration is NS2NP3. NS2NP3. Can you understand, my dear children? NS2NP3. So the last one, please add that one. 2 plus 3 plus 5 oxidation state. What about the 16th chalcogen? What's the general electronic configuration? NS2NP4. So what is the oxidation state? 2 plus 4, how much? 6. So plus 6 is the oxidation. Group oxidation state. What about the halogen? NS2, NP5. So 2 plus 5, how much? Plus 7. So plus 7 is the highest oxidation state. What about the inert gas? NS2, NP6. 6 plus 2, 8. So plus 8 is the highest oxidation state. Can you write, my dear children? You feel any difficulty? Next, one of the very important, other absorbed oxidation state. My dear children, the other absorbed oxidation state is how they are mentioned. This one oxidation state means based on some reactions, some of the reaction, that means 13th group, 14th group, 15th group, 16th group, and 17th group, and 18th group. They have each one, they reacting, they get some of the absorbed oxidation state. For example, boron family, the other absorbed oxidation state is +1, because the boron family, which are the elements are present there? Boron, aluminum, gallium, indium, and thallium. Thallium shows that thallium exhibit +1 oxidation state. Can you understand, my dear children? Thallium, very important one-word question. In the boron family, thallium exists +1 oxidation state. Next, about other absorbed oxidation state, about in 14th group, which are the other absorbed oxidation state, that is about that +2 and -4 oxidation state. So very important, +2 and -4 oxidation state. Okay, before that, one more point we have to learn about that. The group 13 highest oxidation state is +3. We have mentioned like that, +3. Shall we do one example there? We can be recall in the 11th grade, am I right? Just we are going to recall. Okay, I'm going to ask some question. Okay, you have to answer it. Okay, what is the formula for boric acid? Did you have the name boric acid? Boric acid. H3BO3. Okay, H3BO3 is a boric acid, because boric acid, they are having formula H3BO3 means boron having boron compounds. Am I right? Boron compounds. How can you find the oxidation state for the boron? Oxidation state. The formula is H3BO3. Okay, how to find boron oxidation number? Am I right? So all of you know that one. All alkali metal, okay, alkali metal, including hydrogen, sodium, potassium, rubidium, these are all having +1 charge. Am I right? +1 charge, including hydrogen. So H3BO3 means they are having 3 hydrogen. Am I right? 3 hydrogen means we can written as 3 into +1. Otherwise, you can write +1 into 3 plus. You have to find boron, so it is taken as an X plus. How much oxygen is there? 3 oxygen. Don't forget that oxygen, here the oxidation number is about that -2. Okay, don't forget that -2 for oxygen. -2. I will ask the question. -2. So 3 into -2 equal to 0. Can you understand? 1 into 3, that is 3 hydrogen is there, 1 hydrogen is +1. So 3 hydrogen, 3 into +1 plus. Boron is taken as an X. We have to find out the boron. So we have to take it as X. Oxygen having -2, the charge is -2. How much oxygen is there? 3 oxygen. So 3 into -2 equal to 0. So this can be written as +3 plus X. Here 3 into -2 is equal to -6. Am I right? So you have to write -6 equal to 0. What is about the X? X is equal to +6 ms, right? 6 minus 3 is going this side. Okay, 6 minus 3. So we get X equal to +3 oxidation state. So my dear children, here having X, the value of boron is +3. So it become here the group number 13, highest oxidation state, group oxidation state is plus 3. Can you understand, my dear children? Next about we can be do one by one. About the 14th group, other absorbed oxidation state they are having. I am taking plus 2 and minus 4. Am I right? First I am going to write about the plus 2 oxidation state. Here a very good example is carbon monoxide. Because 14th group it goes to the carbon family. So carbon monoxide is an example. So what is the oxidation state of carbon monoxide in carbon? How to find out the carbon? Am I right? Yes or no? How to find out carbon? So carbon I am taking X plus oxygen I told that minus 2. So 1 into minus 2 equal to 0. So X minus 2 equal to 0. X is equal to plus 2. So the other absorbed oxidation state in 14th group is plus 2. Can you understand, my dear children? Next about minus 4 oxidation about in where? 14th group. I am taking one of the very good example is methane. What is the formula for methane? CH4. Am I right? Methane. Can you understand? So methane, in the methane how to find carbon oxidation number. Am I right? So carbon I am taking X plus. How much hydrogen is there? 4 hydrogen. So 4 into 1. We know that hydrogen value is plus 1. Am I right? So 4 into 1 plus is equal to 0. So X plus 4 equal to 0. X equal to minus 4. Can you understand, my dear children? So 14th group having plus 2 oxidation state and also having minus 4 oxidation state. What about the nitrogen? Nitrogen having the highest oxidation state is plus 5. The general outer electronic configuration having that is NS2, N that is 2 plus 3. This 2 plus 3 we get plus 5. Am I right? That's 5. For example is N2O5. If you are finding means we get nitrogen, dinitrogen pentoxide. N2O5 we get the plus 5 oxidation state. Anyhow, what is the absorbed oxidation state? That is absorbed oxidation state are plus 3 and minus 3. Let us we can discuss plus 3 and minus 3. Here plus 3 means I am taking N2O3. I want to find out the nitrogen. Okay, find out the nitrogen, N2 molecules, that nitrogen. So I am taking, there's N2 is there, 2Ex plus, how much oxygen is there? 3. One oxygen value is minus 2. So 3 into minus 2 equal to 0. 2Ex 3 into 2 is equal to minus 6. Minus 6 equal to 0. X is equal to plus 6 by 2. So we get X is equal to plus 3. Am I right? So example is what? Dinitrogen trioxide. The oxidation state is X is equal to plus 3 oxidation state. What about the minus 3 oxidation state in the minus 3 oxidation state in the 15th group? Okay, I am taking ammonia. What is the formula for ammonia? NH3. We find out that ammonia for nitrogen. Am I right? Nitrogen. So ammonia formula is NH3. So nitrogen I am taking X plus, how much hydrogen is there? 3 hydrogen. What is hydrogen value? Plus 1 value. Am I right? All alkali metal having plus 1 value. Okay, plus 1 equal to 0. So X plus 3 equal to 0. S is equal to minus 3. So we get minus 3. So before that, we also find out that N2O5, am I right? That the highest oxidation state of 15th group, N2O5. Okay, what is the formula? What is the name of N2O5? Dinitrogen pentoxide. Okay, N2O5. We have to find out nitrogen. 2 nitrogen is there. It is 2X plus How much oxygen is there? 5 oxygen. So 5 into 1 oxygen value is minus 2 equal to 0. That is 2x minus 10 equal to 0. X is equal to plus 10 by 2 equal to plus 5 oxidation state. Can you understand, my dear children? Please do it work. Okay. Next one we can discuss about that. Chalcogen family. Which family? Chalcogen family. What is about the Chalcogen family? That is about the oxygen family. Am I right? Which family? Oxygen. Here the maximum oxidation state is about that. Plus 6 oxidation state. Which one? Plus 6 oxidation state. That is, example is tellurium oxide. Tellurium trioxide. Okay. The highest one is tellurium trioxide. Formula is TeO3. TeO3. Can you understand, my dear children? Highest. We have to find out that one. Te means we can be taken as X. X plus, how much oxygen is there? 3 oxygen. So 3 into minus 2 equal to 0. X minus 6 equal to 0. X is equal to plus 6 oxidation state. Can you understand, my dear children? Next, having other absorbed oxidation state, that is plus 4, plus 2 and minus 2. What is about the plus 4? Can be taken as a tellurium dioxide, that is TeO2. TeO2. Okay, T taken as X, and oxygen we know that is minus 2. How much oxygen is there? 2 oxygen. So 2 into minus 2 equal to 0. X minus 4 equal to 0. X is equal to plus 4 oxidation state. What's the next one? Plus 2. Okay, plus 2 we can be taken as OF2. Okay, because it is an oxygen family. OF2. Okay, oxygen difluoride. What's the name of the compound? Oxygen difluoride. So here we have to taken as oxygen. We have to find out oxygen. So you taken as X. The previous I told that halogen have which charge? Minus 1 charge. Okay. How much fluorine is there? 2 fluorine. So 2 into minus 1 equal to 0. Am I right? X plus 2 into minus 1 equal to 0. So X minus 2 equal to 0. X is equal to plus 2. Can you understand, my dear children? Next, one more having minus 2. Minus 2 means all of you know that when you're going to take one of the fluorine. Am I right? Fluorine. Fluorine. What is the atomic number of fluorine? 9 is the atomic number. Am I right? So first shell we can be accommodate 2 electron. Second shell 7 electron. How much electron need? 1 electron need. Am I right? 1 electron need for the stable electronic configuration, to achieve stable electronic configuration. So for example, I am taking hydrogen fluoride. Am I right? It gain 1 electron from hydrogen. It become F minus. Yes or no? F minus. Can you understand, my dear children, about that fluorine OF2? Okay. So 1 fluorine having how much? Minus 1. Am I right? So don't forget that. I will ask remaining. I will ask. Okay. Next about the minus 2 oxidation state. Here one of an example. What is an example means? Oxygen exhibit minus 2. Oxygen exhibit minus 2. We know that one. Oxygen already I told about that. Here this compound having chalcogen is an oxygen family. Oxygen also exhibit minus 2. Okay. Next about halogen family. Halogen is a very important, my dear children. For the halogen family, it is a very important. We have no time for finishing to all. Okay. So try to learn first. Plus 7 oxidation state about the halogen. 17th group. Plus 7. Okay. Plus 7 is a very important. I am taking one of the example. HClO4, name of the compound. Perhalic acid. HClO4. Perhalic acid. Okay. Perhalic acid. HClO4. Here, halogen, all of you know that one plus 1. Am I right? Plus 1 plus halogen means we can be taken as X. That is chlorine is X. Plus how much oxygen is there? 4 oxygen. 1 oxygen is minus 2. Am I right? Is equal to 0. So plus 1 plus X minus 8 is equal to 0. X is equal to plus 8 minus 1. So X is equal to plus 7 oxidation state. Yes or no? Can you understand, my dear children? Okay. So the highest oxidation state is plus 7. Next about that absorbed oxidation state. What are the other absorbed oxidation state means? Plus 5, plus 3, plus 1 and minus 1. Okay. We have to find out the plus 5 oxidation state. Here plus 5 oxidation state means HClO3, chloric acid. So H is plus 1 plus halogen means we can be taken as X, and also 3 oxygen is there. 3 into minus 2 equal to 0. Yes or no? So 1 plus X minus 6 is equal to 0. So 1 X is equal to plus 6 minus 1. X is equal to plus 5 oxidation state. Yes or no? Next about the plus 3. What can be taken as a plus 3 means chlorous acid. What is the formula chlorous acid? HClO2. So halogen we can be taken as plus 1. Halogen we can be taken as X. And about the oxygen. 2 oxygen is there. 2 into minus 2 equal to 0. 1 plus X minus 4 equal to 0. X is equal to plus 4 minus 1. X is equal to plus 3 oxidation state. Can you understand, my dear children? So plus 3 oxidation state. What about the plus 1 oxidation state? That means HOF, hypofluorous acid. We can be taken as halogen is plus 1. So oxygen is, we know that about the minus 2. Am I right? So we can be written as 1 into minus 2 plus X equal to 0. So what is about the X? X is equal to, otherwise we can write plus 1 minus 2 plus X equal to 0. X is equal to plus 2 minus 1. X is equal to plus 1 oxidation state. Am I right? Plus 1 oxidation state. HOF. What about the minus 1? All of you know that one fluorine. Okay, fluorine getting 1 ion means we get F minus ion. So plus minus 1 oxidation state. What about the 18th element? 18th element means they are completely filled. Am I right? They are completely filled in their p subshell. They never gain electron. They never donate an electron. They are completely filled. They are stable. Am I right? So the electronic configuration, we know that one. 1s2, 2s2, 2p6, 3s2, 3p6. Am I right? 1s2, 2s2, 2p6, 3s2, 3p6. And about their electron shell. Electron shell means 2, 8, 8. Am I right? They are completely filled. Anyhow, my dear children, today our assignment, try to write the electronic configuration. Try to write the electronic configuration for the group number 16 element. Okay, group number 16 element, that is oxygen, sulfur, selenium, tellurium and polonium. Okay, this is the general question I am giving. Write the electronic configuration of group number 16. Okay, thank you all of you. Thank you. Have a nice day.